So the first bit of information we have here is the fact that O is the center. So I want to look at all the theorems that deal with centers and mark them out on the diagram. I'm going to start with putting the center there, and then I want to look at angle at center. Okay, so I do have that. I've got here, I'm going to call it a 2x, and I'm going to call the F1 an x. It's F1 and 2, sorry, all of them together. Okay, so I'm looking at radii and I'm seeing, do the radii give me anything? But I don't seem to have any triangles created by radii, so nothing there. Do I have a diameter? No. With the radius, do I have a tangent? Let's double check. Radius, that meets tangent GH. Okay, so yes, I do. So I've got a tan rad because it's coming from the center there. And for now, that seems like almost enough, excepting I'm given this thing I'm seeing on the diagram, AB equals BC. Okay, so that's given as well in the information, which means I have another 90 degrees coming out there. I'm just going to make B1 also 90. It is 90, but I'm going to mark it as well just to be really clear with myself. Okay, so dealing with the center helped me deal with that was also given and the tangent. Wait, is there a tan chord? So G3. Does G3 link to anything? That would be that FG needs to make an angle at the circumference and it does not. Okay, so I've dealt with the tangent. Okay, EAGF is a cyclic quad. EAGF. I'm wondering now about opposite angles of a cyclic quad. So I'm just going to make a note here because if I go and mark stuff, I think I'm going to make a huge big mess. So I'm wondering if I can maybe go back there and then deal with opposite angles. Then I've got parallel lines. I'm going to highlight those guys. Do you see I went and highlighted GH as well? Well, where do I come from with that? Well, B2 and 3, that's 90, and then the G2 and 3 is also 90, so I've definitely got 3 lots of parallel lines, and they're all parallel to each other, so that creates some interesting dynamics for alternate angles. Again, there seems to be a lot of them. Okay, so that gives a lot. So my x that I marked out there, my F1 plus F2 as my x, I'm then going to get a z coming here. Okay, so that means G3 is also x in my diagram. And is there another one? P2 is also x. I'm going to actually just leave that and see what I've got to do first before I go and add a whole lot more. Radius OG I dealt with. This I'm still coming back to, so I'm just going to underline it. EO. Okay, these things are joined. Yeah, I don't find that particularly helpful, but okay, I'm seeing it. Right, the first thing I've got to do is prove that B2 plus F1 equals 90. And I think the way to approach this is to not freak out by the fact that they're telling me now I've got to prove something is 90. What I've got to think about is, like, where are there 90s in this whole thing? And I got something like that. I got B1 is 90. And then I got B2 and 3 together are 90. That's interesting. B2 and 3 together are 90. Where's F1? Okay, F1. We do have this other Z here. I'm going to change color and mark it out. So I said I would come back to the alternate angles and I came back to them rather quickly. Can you see that F1 and B3 are the same because of those parallel lines? Okay, so I'm just talking it through first, and I'll do this in my head as well before writing anything down. B2 and B3 I know are 90, but B3 equals F1, so therefore B2 plus F1 is going to be 90. So what my tricks are, and I think this is worth writing down, is that I'm looking for replacements to be able to go back and then get these two weird things that equal 90. I'm saying, well, like, what else equals 90? And where are there 90s anyway? There's also the G2 and 3, which maybe that's coming later. But I'm trying to replace, I'm not looking at B2 and F1 and going, oh my gosh, how are these going to be 90? I am looking at where is B2, where's a 90, where's F1, and then I am putting the pieces of the puzzle together by taking them from different parts of the diagram. So let's lay it out. I need to start with where I got the 90 from to begin with, okay, because my starting point here was the fact that B2 plus B3 was 90. And then I replaced the B3 with F1, okay. So I get that as 19. What was my reason? That was the line from center. There's a pause there for a purpose. What does the line from center do? We got that it bisects the chord. That's why I get the 90. So I must put down what I have, not what I got from what I have. So line from center. Some of the reasons say to midpoint of chord. I'm happy with that. Or you could say bisects the chord. Okay, you could have also laid this out and said AB equals BC given, therefore, and so on. So then I want B3. I want to replace B3. So this is a replacement exercise. B3 is the same as F1. Why? Because they are alternate to each other in the first two parallel lines. Remember, I proved that last one, so maybe I can use it, maybe I don't have to. We'll see. Then I've got to prove that G3, which I've labeled X, that is the same as F2 plus B3. So again, I'm going to try and look for a way of replacing with that. Okay, so I can see here that there's going to be another X because I've got my parallel lines. There's going to be another X over there, alternate angles. So I'm going to prove the parallel lines. Then I'm going to say, okay, so P3 equals X. I'm going to add that in. And X equals B3 plus F2 because it is the exterior angle of triangle FBP. So that's how I'm going to do that one. The first thing I've got to do is I've got to prove parallel lines. So I'm going to start with that. I'm going to say B2 plus B3 equals 90 degrees. And I'm just going to repeat, I've proven that, so I can say proven. If you're ever unsure, then just go and rewrite the reason, okay? Also, G2 plus G3, that equals 90 degrees, and that's because of tan rad. Therefore, AC is parallel to GH. And my reason was converse corresponding angles. Then I'm going to say P3 equals G3, and they are alt angles from my parallel lines. And from that, I'm then going to do the exterior angle of the triangle. So I'm going to say P3 equals F2 plus B3. And my reason was exterior angle of a triangle. I'm going to name the triangle. You don't have to, but I find it just helpful to kind of know where I'm standing with it. It's PFB. Therefore, G3, which I already said was the same as P3, that one equals F2 plus B3. To handle this A1 equals G1 plus G2 thing, I went over the cyclic quad that they gave me, EAGF. And the reason I did that is because I could see the G1 plus G2, like what makes them significant? Well, they are this opposite angle of the cyclic quad, and they're opposite to E1 and E2, right? Okay, so they will add up to 180. So then the next thing is, does the E1 plus E2 my replacement, because that's not in the question, does my replacement add up to 180 with something else? And sorry, I crossed the one out there. It does, because you've got your parallel lines here, your blue things that are highlighted. Okay, so the way it's going to go there is I'm going to start by saying A1 plus E1 plus E2. Those guys equal 180 degrees because they're co-interior, right? But then those guys, the E1 plus E2, they plus the G1 plus G2, the opposite one in the cyclic quad, okay, they add up to 180. And that is opposite angles of a cyclic quad. And now it becomes clear why the question gave that to me to begin with. So now I've got A plus that thing equals 180, then that thing plus G1 plus G2, therefore A1 must be the same as the other thing that got added to get 180. The next one is that B2 plus G3, who are nowhere near each other, equals F2 plus 90. So again, I'm just looking for replacements. Okay, so yeah, B2 and what else? What does B2 equal? And where is the G3 in it? Okay, so let's look at B2 being an exterior angle of this triangle here. So I'm looking for what else B2 can be. And the triangle BFG, I'm going to say angle B2 in that triangle, because I'm trying to get close to G. Okay, so B2 equals F2 plus G2. And that's because they are exterior angles of a triangle. Sorry, the B2 is an exterior angle, and I'm going to name the triangle BFG. Okay, how does that help? Well, F2 is in there somewhere. Let's look at where we can get G3. G3 works with a 90 and G2. So I'm going to say G2, so I'm repeating G2 there, plus G3. Those guys give me 90. That was my tan rad. So now I'm looking to see, because I want B2 and G3 on those two guys to add up to F2 and 90. So I've got them somewhere. I've just got to rearrange and replace now to get it to look like the little arrangement that they've put over there. So let's rearrange this one. G2 equals 90 minus G3. Just fiddling around a bit to see if I can get things to be equal. So then replacing now here, that G2 with the 90 minus G3, I can say B2 equals F2 plus G2, and G2 is the 90 minus G3, so that's plus 90 minus G3. You see, I'm putting no reasons down here because I'm just replacing stuff. Sure, that looks a lot like what I'm supposed to get. I'm supposed to get B2 plus G3 equals F2 plus 90. This is just rearranging an equation now, so I'm just going to go B2, and I'm going to move the G3 across. G3 there equals F2 plus 90. So sometimes this is just about figuring out how to rearrange and getting quite a bit of practice in rearranging. Okay, so let's do some replacing here. Let's look at what else O1 is. O1 equals, I did something here. I had the 2x in the center, and then I had the x here, and the x was F1 and 2 together, right? Okay, so O1 equaled twice, and let me just keep the numbers of the letters as they called them. It It was the F1 plus F2. And that was angle at center. But then I must link this to, I'm going to try and link the G2 and the F1 plus F2. So where's G2? G2 is in there. G2 is this little one there, G2. Okay, so I need them to not necessarily be equal to each other. I need, because I want 2 of G2s plus O1 to give me 180. My X, my F1 plus F2 there that I've gone over in purple. Look, we've got a Z here. And we did actually write this down earlier. It's there, right? So then this is the same. Okay, my F1 and 2 also equals G3. Okay, so I'm going to put that down. Try and get a little bit closer to G2. So F1 plus F2. Those guys equal G3 because of alternate angles. And I'd already proved the parallel line, so we're good. Okay. But then the G2 plus 3, now I'm getting closer to G2. G2 plus G3, they were 90 together, and you can see I'm getting close to the 180. Okay. They were 90 because of tan rad or proven. And then you can rewrite G3. You can rewrite G3 as 90 minus G2. Okay, how does that help? Well, here we've got O1 equals 2 of F1 and F2, but they equal G3, right? So therefore O1 equals 2 of G3. Okay, and then I can replace the G3 with a 90 minus G2 over there. So then I can say, okay, but O1 equals 2 of those guys. And now I'm getting to my 180 minus my G2. Okay, once I've got that in place, I can now say I can multiply out. So I can say O1 equals 180 minus 2 of G2. Do you see how I'm getting closer? Well, I'm actually there. 2 of G2. So I want O1 plus 2G2 equals 180, this thing here. I've got it. So now I've got O1. That one now, if I just move the 2G2 across, I've got it. It's that together equal 180. So again, just a hell of a lot of replacement. For the last one, I've got to prove that O2 equals a whole bunch of other things here. And I'm just going to look at what else O2 can be and then see if I can equate them by replacing out. Okay, so O2, what was that? Okay, so O2 is, interestingly, it's that reflex angle. And that's the only thing it can be. I mean, it has to link to something to do with angle at center, right? So O2 is twice of A1 plus A2. How's that helpful? Well, there's an A2 there, so let's have a little bit of faith and put it in there. Okay, so O2 equals twice of A1 plus A2, and that's angle at center. Okay, so I think we should split this up here. So let's just multiply in my 2. The reason I'd multiply in the 2 is because here I've got 2G1, 2G2, 2A2, and I want to get a 2A2. So to get a 2A2, I'm going to have a 2A1, which I'm not comfortable with, but I'm hoping I can replace the 2A1 with something else. Okay, let's see. What can I replace the A1 with? Okay, I'm going to do it here on the left-hand side. Okay, A1. A1 is G1 plus G2. This was given earlier. Why would I want to go back to that? Because of the G1 plus G2 there. Okay, I think I'm going to make this look easier than it is. A1 is G1 plus G2. Okay, therefore, I'm just going to replace now. Okay, my O2, oh, I should write here proven, even if I didn't. Okay, even if I couldn't prove it, it was like supposed to be proved earlier, so I'm allowed to use what I've already allegedly proven. So O2 is then 2 of A1, which is G1 plus G2. Okay, and O2 plus still the 2A2, so I got that far earlier. And now I'm just going to multiply out. Okay, so then I'm going to have 2 of G1 plus 2 of G2 plus 2 of A2.